So the context for this tutorial is to learn how to use Creo Elements Pro, one of PTC's top pieces of software for 3D design. To teach you Creo Elements Pro, we need a context, and we're going to use this simple construction kit as an example. So that's the outcome that we're going to be working towards, and showing you how to model a corner cube here and one of these struts that connects the corner cubes. So the concept is a construction kit. We'll need to make some decisions about key dimensions for the distances between the cubes and the lengths and dimensions of things like the struts and the cubes themselves. So how might a designer develop a concept such as this? Their idea would be firm in their mind, so they'd have that picture that you've just seen, albeit maybe a little bit hazy in their minds. So now they're going to use 3D sketching in order to get over the concepts to colleagues that they might be working with, and to help them formulate their ideas before modelling using the 3D software. So we might start off with some centre lines to show the axes along which the cubes are going to be constructed. For the purposes of this sketch, I'll only show the front parts. The model. So here you can see the front three faces of the cube and the corners where the joining blocks are going to be located. So let's sketch in this position here one of the corner blocks. So we'll have some rounded corners. With a corner at the front here, and then on each face we'd have the hole where the struts are going to fix into, and obviously there'll be 3 holes around the back here. So let's make some decisions about the major dimensions for this. So the cube itself, let's say the cube itself will be a distance here of 30 millimeters, and the designer would be maybe developing this as they go on. They may need to change some dimensions. We'll have this hole here, 8 millimeters in diameter. There'd be some rounds on these corners, so let's say 5 radius, and maybe some chamfers on here of 0.5. So that's located at the corner of each one of these. Now we'll sketch out a strut, and we'll sketch the strut in this position along the bottom here. So it's going to have pegs on both ends, so perhaps the easiest way of modelling this would be to draw a circle somewhere in the centre and extrude that equally in both directions to make the piece of material, the rod that's going to fit inside the corner block at each end. That'll go into the corner blocks 10 millimeters here, so that'll leave 5 up to the centre line, another 10 here and 5 up to there. So I've got to remove 5 from the distance between here. We haven't made that decision, so let's put in a centre to centre distance here of, let's say, 100 millimeters. So we need to take 5 off at each end, that's 90 long. So this strut is going to be in the region of 90 millimeters long. We'll then draw a slightly larger circle and extrude that equally in both directions to make the larger diameter, and the purpose of this is to create the shoulder at each end so that it goes into the cube by exactly the right amount, and the length of that one will need to be in the face, between the faces of the cube. So from this centre line there'll be 15, same at the other end, so take 30 away from the 100 millimeters and we get a distance here of 70 millimeters. Make a decision on some diameters now. So this one here would have to fit in the hole, so that's the same as that, 8 diameter. This needs to be bigger, not massively bigger, but to stop it going into the block too far. So let's say 12 diameter there. And then to make this a little more interesting, from somewhere here we'll put a curve on. And that curve would be down to the smallest diameter there of, make it the same as that, 8. And the full distance of that, if that's 70, we'll make the distance here something like 60. Okay, if we look briefly now at how we might construct these so that we're starting to think about the modelling strategy. Well, the cube, we might start on one of the vertical datum planes by, it'll be extruded, but we'll do that with an internal sketch. So we'll start an extrude and then we'll sketch maybe on a vertical datum the cube. There'll be reference lines there to locate the centre, and we'll do symmetrical about these. So that will be 30. These will be equal length, so L1 and L1. These will make more sense as we get into the modelling. And we'll put a datum point, a geometry datum point in the centre there. You'll see why later. That then we will take the sketch and we'll complete the extrude. So the extrude will be in this direction. The sketch will be through the middle, so there's where the datum plane was for this sketch. So that will be 30 millimeters. And symmetrical. The next bit would be to add a hole, and again we'll use an extrude for this. There's another method we'll see in a moment. So we will draw maybe on this face here a circle, diameter 8, so that'll have an internal sketch too, and then we will extrude that in this direction through all, and again that will make more sense when we get to it. We will repeat that so we have one there. We'll repeat that as another hole here, so that's another extrude. So you get plenty of practice on extrude, and then the final hole we'll do differently. So those are already in place, and this time we will use the hole feature, and the hole feature will have a diameter of 8. It'll be centered in the face here, and it will be through all. Okay, so that's the cube corner and the way in which it will be modelled, and now we'll do the strut, and the strut I'll do down here. So we'll start off with, again, an extrude with an internal sketch. Here's the datum plane, here's the circle, diameter 8, then we'll completely extrude here, There's the sketch that created it, and we've said here that this will be 90 long. We'll then start another extrude with an internal sketch, and this is for the larger diameter, so this already exists. We'll do the sketch here in the middle, and then that will become extruded to make the larger diameter, a distance of from here 70. We'll then do something to make this a little lighter. So we already have this in place. And so on a datum plane that runs through the model in this direction, we will create a circle, centre up here somewhere, and use that trimmed off to revolve and remove material. And the critical dimensions, the critical dimensions here are the diameter in the centre, and these distances here, so we can represent that by showing the horizontal distance along there, which we said was 60. That will be revolved around, removing material to leave the wasted shape in the middle of the strut. And that's how the thinking might have gone on in order to develop the concept. The next step is to go on to the 3D modelling.